Hello everyone, my name is Indrapreet Binning and my technical advisor is Dr. Wang. My project is titled Improving the Mechanical Properties of 3D Printed Parts Using Fused Filament Fabrication. So what exactly is fused filament fabrication? Well, it's technology used in 3D printing, and this technology works by heating up filament and depositing filament side by side on a print. As you can see on the illustration on the left, the material is deposited side by side, and then as each layer is completed, the process is repeated until the print is finished. The animation on the right side does a very good job of showing us this technology in action. So some of the advantages to fused filament fabrication is that it is relatively inexpensive, you get pretty good resolution, there is a variety of materials to choose from, and changeover is easy when compared to other technologies in 3D printing. There are some disadvantages as well. Some of these include the surface finish of the parts, the consistency of the prints themselves and how they vary from print to print, and the biggest drawback, which is the mechanical performance of these prints, or mechanical performance of prints that are created using this technology. And so fused filament fabrication lacks in the mechanical performance, and this is due to the fact that the process itself is anisotropic. What that means is that the properties of the process are varying due to direction or orientation. So if you were to compare, for example, a tensile load in the X direction compared to a tensile load in the Y direction. So in this illustration right here, in order to cause a failure in the X direction, I would actually have to apply a tensile load and pretty much pull these fibers apart. If I were to apply it in the other direction, in order to cause a failure, I would just need to overcome the strength of the bonds themselves. And so, as you can imagine, it's going to be easier to break apart the bonds itself, whereas it would be very difficult for somebody to pull apart at the fibers and cause a failure that way. And so the industry acknowledges that there is a lack of mechanical performance due to this process itself. And so the industry has come up with some sort of post-processing technique. So what that means is that after a part is done being printed, some sort of processing is done afterwards to improve the mechanical performance. One example is called infiltration. And so in this process, what happens is the print is either submerged in a resin bath or it's coated with the resin, and what it does is it pretty much infiltrates the material or the surface of the print itself and kind of hardens and turns into a glue. And so how does this actually improve the mechanical performance? So if we were to take a look at this print right here and actually cut it into a cross section, we would get something that looks similar to this right here. And so what infiltration does is, if you were to see some of these empty voids in between the actual filaments themselves, the infiltration, what it does is it fills these voids and it hardens, and pretty much what it does is it's kind of like a glue. It just holds everything together and makes the print much, much stronger. And so resin infiltration is a good post-processing technique, but the issue with it is that it takes a very long time to cure. And so cure times depend on how large the actual print is, but most times the curing time for this resin infiltration is longer than the printing time for the part itself. And so the industry and researchers have found a variety of different solutions to this problem with the mechanical performance. However, what these solutions fail to take into account is the actual overall processing time for the entire process. So, as I mentioned before, for the resin infiltration, you have the time that it takes to actually make the print itself, but then you also have the addition of the processing time and the curing time, which will add up, and in some cases, depending on the size of the print, it could take over 24 hours to cure a print. And so what this project will be doing is it's investigating a new post-processing technique, and it's also taking into account the time for that post-processing method. We're trying to minimize that as we go through this entire process. And so Dr. Wang approached me with the idea of using a high-intensity lamp to investigate and see if this would be a viable option as a post-processing technique. And so the idea behind this process is that, say if we were to print a single layer and then we were to flash it with the lamp, we want to see if the lamp can provide enough energy to pretty much remelt the filament itself and then cool it down, and while it cools down, pretty much form a better joint with the filament around it. So what we want to do is we want to see if it is possible to pretty much have a homogeneous layer. And so this would be done layer by layer by layer. So you would print a layer, and then you would flash a light, and then you would print another layer, and then flash the light, and see if you could get it to where the layers are homogeneous and there are no gaps in between layers. So this project will be pretty much a design of experiments project, and I would be using a machine called a Sinteron, and this would be my high intensity lamp, and I would be adjusting some parameters on that machine and seeing the effects that it has on this response variable, which is the layer height, and this other one, which is going to be the actual height of the neck. After that is done, optimization will be done to figure out what exactly is the best setting using this machine. And so the parameters that will be adjusted on the machine itself will be the voltage, the number of pulses emitted from the lamp, and the distance that the material is from the lamp itself. A trial experiment has been conducted, and here is an image on the right hand side, and as you can see from here, these are some of the sample pieces that were used in this experiment. So these pieces were white when I initially started, but after playing around with some parameters, you can see majority of them are burned. And so the trial experiment, some of the findings that I got from the trial experiment was that a high level of voltage caused burn marks on the actual material itself. It isn't desirable. However, if you increase the number of pulses, you do get something that is desirable. You get a smooth finish. So for the actual levels of the parameters, we're hoping to use low voltage but increase the number of pulses. In summary, this project will be investigating a new post-processing technique to improve the mechanical performance of 3D printed parts using fused filament fabrication and then doing optimization. So I hope this video was informative about my project. If you have any questions, feel free to contact me via email at ibidding@calpoly.edu. Thank you for watching.